Hello guys, Free here. Welcome to the presentation for today. In today's presentation, we're going to talk about data modeling within the modern data landscape. It's a very exciting presentation we have. We're going to do a really interesting demo of a product, SQLDBM. But before we go into that, let's maybe take a step back and rationalize why this is a very important topic for teams that are looking to modernize their data landscape or their data stacks. If you do a quick search on Google, more than likely you're going to come across a diagram or chart that looks like this, cataloging the current tools available for data engineers or folks working within the data ecosystem. And these tools would address the typical areas you would imagine, everything from data integration all the way to data quality, data discovery, and more emerging areas like notebooks and virtualization, which kind of is a little bit of an older area. But the piece that is missing here quite a bit, and is actually very glaring, is the whole area of data modeling. Data modeling is a very powerful area for data teams. And as teams are evolving and modernizing their data ecosystems, you cannot do that while ignoring data modeling. There are just so many capabilities that comes with it. And we're going to talk about that today, as well as do the demo that we have in store for us. So it's going to be a very exciting presentation. Now, from a modern data modeling perspective, when people think about data modeling, we think about diagrams, and we're going to define it shortly here. And what we want to focus on in today's presentation is to talk about some of the design tools, and this is why people would want to do data modeling in their stack. Database diagrams. People are sometimes more visual than we can read text, so having diagrams could be very relevant, or just needing capabilities for data engineering or reverse engineering or forward engineering as well. So being able to take SQL and translate that into diagrams, or take diagrams, visual diagrams like this, and translate that into SQL. So these are some of the three key reasons that push teams to look at modernizing their data modeling ecosystem. Now, if you work within your modern data ecosystem, your modern data stack like Snowflake, as you all know, Snowflake is a modern data warehouse solution for massive amounts of data with compute and storage, allowing teams to really crunch through and process data at light speed with very seamless scaling and in a very cost-effective fashion. Definitely a go-to platform for data warehousing teams. But if you log into Snowflake, this is the UI that teams are welcome with. It has your typical constructs you expect from a data warehouse. You have tables and columns, and within those columns, you have rows and tables. And of course, you can write SQL to access that data. Now, if your goal was to work with one table within one schema with no relation to any other table, it's very simple, very easy for you to come in here and write your SQL statement, and everything should be good. But if we're talking about working in an environment, and this is something that will be very common for production teams, where you have hundreds, if not thousands of tables, hundreds of views, many different schemas with very complex relationships across different tables, having an easy way to visualize that becomes essential. And that's where data modeling really comes into play. A very thorough and robust data modeling framework would be relevant in that case. Now, if we take a quick definition here of what data modeling is, just to lay down that foundation, if you Google online, you'll come across the definitions, but this is the one that really stood out to me. Data modeling is the process of creating visual representation, and visual here is really important, of either the whole information systems or part of it to communicate connections between data points and structures. So a couple of things are really important here. The visual representation part of things. So if you're going to look for a data modeling tool, you're always thinking about how does it make this, or how does this help us from a visual perspective? And how does it show or communicate those connections between my tables, between my objects, between my schemas, so my team can collaborate on that data and understand what's going on. So this is one of the reasons why data modeling is a very important aspect for teams to think about as they modernize their data landscape or their data ecosystems. Now, there are many different types of data modeling. We're not going to go into every single one of this. Everything from your entity relationship diagrams, which is a more formal approach, all the way to object-oriented data models, common with programming languages like Java or C++, and or your dimensional data models, which was popularized by Ralph Kimball with the data warehouse and the dimensional modeling approach. So these are some things that teams are typically very, very aware of. And there are benefits to each of this, and you might use them in different areas depending on your needs. So just to kind of drill down a little bit into that, if you're thinking about modeling your data, you'll be thinking about your conceptual data models, your logical data models, and then the physical ones. Not to go too much into this, but basically conceptual is the very high level. Think about just the names of the tables you have within your database, and then potential relationships that exist within those tables. Now, we don't know what is in the table. We just know, for example, it's a time table as such, or a time object, or a product object, or sales, or inventory, or manufacturing. You can just have this conceptual data model. Logical gives you a little bit more details, but again, not a whole lot. So it might tell you what attributes or what columns are within those tables and the relationships that exist are within them. When we talk about physical data modeling, this is where really going down into the granular detail of what are my column names specifically. So not just descriptive column names, but the actual physical column names that exist within the database, as well as the data types. So depending on the database you're working with, your physical model might be a little bit different from your logical model, given the specific requirements of that database. So just having a foundational understanding of this is very important as you think about a data modeling tool that can give you capabilities to represent your conceptual models, your logical models, and your physical models. Now, the concept of reverse engineering becomes very important, where you're thinking about translating your physical model into code. So if you have a data modeling tool that allows for collaboration for teams to either do physical designs and forward engineer that into generating code, or they can reverse engineer, which is basically looking at code and then working back into a physical diagram that can be shared or folks can collaborate on within the team. So this is usually why people gain value from a data modeling tool or data modeling infrastructure. Now, here are just some of the key benefits to think about if you're looking at modernizing your data modeling stack. It helps with documentation, of course, very visual. You can use it for reverse or forward engineering, as we've seen here. You can start with SQL, which is what folks are pretty familiar with, and work back to your visual diagrams, or you can design the visual diagrams and generate SQL from that. This could help tremendously when we think about being productive. Some folks can really create diagrams quicker than they can write SQL. And if you can create your diagrams, document those diagrams, and generate SQL out of it, now you have a very consistent environment for folks to collaborate, which could be very effective. It's readable. You can maintain consistent standards and really plug this into your software development lifecycle. Now, some of the players within the space of data modeling has evolved over the years, and it's kind of been interesting to see the industry really change as we have modern stack or modern data tools coming online, with Snowflake really leading the way. This is pushing teams to embrace the cloud approach, the cloud native approach, to embrace not having to install bulky softwares on premise, and to embrace agile stacks, right, where you're integrating with Git, you're integrating with a lot of build tools and allowing for innovation within that stack. So these are some of the legacy, I would call it legacy, players within that space that allows for data modeling. But what we're saying too is this new push towards the more modern data modeling tools, and SQLDBM is one of them, which we're going to talk about in today's demo. And this will be actually a series of demos I'm going to do here, exploring some of the modern data modeling tools and just having a conversation and a demonstrations around them. So stay tuned for that as we progress through this series of lectures. SQLDBM is a very powerful data modeling tool. We're going to dive in today, see the demo of SQLDBM, and then have some conversations at the end. Now, to access SQLDBM, it's all cloud-based. It's delivered as a service. So if you think about wanting to have your team be empowered with the data modeling tool, all they have is go into the browser. I believe there's a free version and there's a paid version. I'm not going to talk too much about the pricing, but just really focusing on the capability of this tool. So as always, we're going to be working with our Snowflake environment, seeing how we can come into Snowflake. In our previous demos, we can write SQL statements here. But if you're going to build a really complex model or a complex system with hundreds or thousands or even just a few dozen tables, and you still want to have consistent documentation of the relationships in a visual fashion, having a tool like SQLDBM would be especially relevant. So what you're going to do when you come in here is we're going to log in. I already did that. So you can log in with your account, and it brings us into this interface. And it's a very cloud native interface, like a lot of the projects are going these days. And you can do a couple of things. You can create a project and work within that project. Now, I'm using the free trial version here, so it's not going to be up for long. But this particular version allows for just one project. So if you think about a project, you can consolidate all of your work items within a project based on how you structure that in your organization. It could be very flexible. Since I have a limit of one project, I'm just going to go back to the project I had here already. And this should bring us up into the UI. And the goal here is just a quick walkthrough of the UI, just so you're familiar with it if you're going to be using this as part of your flow. It's very intuitive and very straightforward. If you've worked with any other data modeling tool, this should be extremely familiar. So talking about, I've worked with Toad, like Erwin, and many other that are out there. This makes it becomes really familiar for you to understand what's going on. So on the top right side here is what impressed me is the whole idea of collaboration. So once you come in here and you're working on a project, I'm not going to be able to do this today, but you can share the project you're working on. So you can invite team members, you can invite other folks on the project team to collaborate and develop all of this. So which is really one good benefit of this. So instead of you having to share files and move things across the world, having a place where everyone can collaborate could be very effective. Now, coming to the left side here, we have kind of a menu bar. The very first one here shows us the diagrams. And what we have on our screen here is a sample diagram that I imported. You can create your own diagram if you wanted to. And there are a couple of areas. You can see the simple diagram, high level view, which is more of, if you remember, it's more of the logical or the conceptual view of your data model. And then you can go ahead and try yours and physically create it. All right. So if you go back into the sample diagram, so this is a sample diagram provided as part of the project. You can edit any object within that and modify the physical attributes of this particular object. So if I wanted to say, hey, this column is a date, is it date time, you can change all of those attributes. And as you're done, you can save them. Now, I can't really save it working with the sample data here, but I think we get the point. Now, once you've built your model and you have a really exciting model, the next area we want to look at is just exploring that model. So this brings us into the exploration view or the diagram explore view. So in here, it gives you more of a linear or a list way of exploring your data or your model. So we can select customer dimension in this case, and it takes us to that particular object within the data model. And you can then go ahead as before. We can edit this. If I wanted to change the customer ID, I can go ahead, change that, and let's put customer IDs. And now my physical model has been changed. And you can do the same thing for all your dimensions or all your fact tables. And as you go through, you can add notes and comments along the way. There are abilities for you to select items as you go. You can zoom in and zoom out. You can add a table very quickly from here. If I wanted to add a new table to this model, you can do that. So let's say tech with through demo. I can drop in a table and begin adding my attributes. So first name, we can give it a data type, let's say string, and it auto-completes for us. If I want to make that into a key, you can go ahead and make that into a key. All right. And if you want to add more attributes or more columns, you can either just use that and add, or as you add this as such, it brings that for you. Now, if you want to create relationships between the tables that we have in here, we can just basically drag that. It's not going to be very effective, but you can see now I have a relationship between my table, which we just created, to my customer dimension. And you can see now there is a primary key showing up in there, which I have to set for that relationship to be very effective. And as we're doing our modifications here, you can also modify those properties or the attributes we've set up on the right side of the canvas, of the design canvas here. So this gives us just a visual way of designing the schema or the ERD, the entity relationship diagram, from a physical model perspective right here within the tool. Now, the next aspect that we're going to see here is, and we'll talk about this a little bit later, is we've designed all of this. How do we forward engineer this? How do we generate the SQL that can then be pushed down or executed to generate those tables from Snowflake? Because nothing stops us from coming here and doing a create table here in Snowflake and manually putting those attributes. But we want to save time doing that. If you have 100 tables to generate and create those relationships, it just might be more effective for us to do that here and forward generate that SQL, so we can use that on the Snowflake side. But continuing down here, we have kind of a diagram explorer. We have as well the next one is basically the database explorer. So this gives us an exploration of the different schemas that we have. If there are file formats that we want to create, very similar to what we have in Snowflake, we can explore those file formats and make changes to the file formats here on the right side. We can see the tables that we have, just another view of what we saw before, but just giving you more ways to really drill down into the objects that we've created. We can also see our relationships or any references or views we might have created within our ERD or within the data model that we have. Now, the next piece here, and this will be very relevant for governance teams or teams that are thinking about documentation, is the next aspect here of database documentation. If you have a complex database with lots of users, hundreds of users, tens of thousands of users in some cases, you really want to make sure you have good documentation. Going back to Snowflake, if you're creating a table, within your tables, let's pick one of my tables here, having a documentation of what is this column, what is this attribute, what is the description of it. The semantic type that goes with this becomes extremely relevant. Without it, teams are not very informed in terms of what you have within your environment. So going back here, it allows us to go back to the documentation. Let's bring this back. We can pick, say, the different objects that we have, and now add very specific documentation. This could be an entire team doing the documentation separate from the developers. We know developers usually don't like documentation, unfortunately. So you can have the developers working on the physical design, and at the same time, the documentation team or the analyst team are coming in with the appropriate documentation. All right. So let's say all customers subscribing to Tech with From. Okay. And now we can have very robust detailed documentation tied to the data models we've created in a very collaborative fashion. And this is the benefit you get from having a data modeling tool to work with as part of your data ecosystem. Now, if we've created our documentations, we save that, and now we've had a catalog or a glossary of terms defined. And if we had a data catalog, once we create these objects in Snowflake, which we're going to see here shortly, your data catalog, which is say Alation, Colibra, or all the different data catalogs that are out there, can then harvest this documentation or this metadata we've added to feed your data catalog and give you a true representation of your data. So this is something that I definitely will not ignore as you're going through creating your models within SQLDBM. Now, I'm not going to go through and create all the documentation here, but I think we get the point. You can document attributes as well as relationships, right? Why is this relationship necessary, and what should be considered when using this relationship? So just some things to think about. Now, the next piece here is version control and just collaboration. You're going to work on your data models, and as you're iterating through all of this, you're going to have different versions, right? What version made it to production? What version is being used today? And you can create all those versions, maintain the versions here, and really collaborate with it. I'm not going to spend too much time, but I think we get the point of the different versions that we have coming up. Now, the next piece is after creating our design and the relationships and the documentation, is we want to forward engineer this. So basically, we want to generate the SQL that allows us to take this and instantiate it within our ecosystem here on Snowflake. All right, so we want to go from the visual representation into the code that we can run to create all these tables on the Snowflake instance. So here's the forward engineering. We can select that. And this allows us to generate the SQL that we can then execute on Snowflake. Unfortunately, I can generate SQL for just one table, but if you had hundreds or thousands or tens of thousands of tables, you can basically select what tables you want and say, oh, views, I have no views, and you say generate SQL. So it's going to generate SQL for just one of these tables for me. But if you had the upgraded version, you can generate you can create the DDL for all your tables. Now, once I have that, I can basically copy the script, go over into Snowflake, and voila, I've got my my DDL ready for me to execute, very confirmed with the appropriate documentation tied to it, easy for me to use, right? With the file formats and all of that, that is consistent with what Snowflake expects. So think about the time savings. Instead of me having to manually write this, now I've got my documentation of it, which is version controlled within my modeling tool, and you can really accelerate your development lifecycle with this. Now, if we can forward engineer by generating the SQL code, the next logical question is reverse engineer. And this is an aspect which is always very important as you think about your data modeling tool. So reverse engineering allows us to look at an existing environment that we have and generate or document the structure out of that back into a data modeling tool. And here we can do that as well, which I'm going to show here. We can connect to a DB environment. I have a Snowflake, and so we're going to connect to my Snowflake demo account. Basically, we're going to copy this, bring that into my server. My username is TechWithFru, of course. We're going to put in a short secure password. Role is going to be optional. And what this is going to allow us to do is to connect to my Snowflake instance. And with any log, we're in, so you can see my instance has been connected to. Let's go back here. And what you see is it's basically introspected this environment and it's pulled out all the different schemas that I have. The DemoDB, the sample database, as well as my utility database. So if I go back, those are all the things that shows up here, and I can drill in, maybe select a specific schema if I wanted to. Let's bear with me. Let's just go back in here for a second. I can select my database that I want to reverse engineer. I can go in, select the specific schema. If I want to just bring in a specific schema, I can bring that in, or I can bring this for DemoDB as well. Let's bring it just for one, and apply that. So what this is going to do, it's gone into Snowflake. It's pulled out the DDLs for all those objects within the schema I've selected, and it's made that available for me. Now, if there were relationships too across my tables, so you can see, I think I have 2 tables, IoT feed demo, a couple of views as well. So those are the objects that I have showing up in here. All of that has been pulled over to my tool and made available for me. And if you want, you can save this and then visually see that in your the diagrams perspective, which is what could be very relevant. So let's go ahead, save for, let's see if we can force save that. And I think that hopefully it should save that for us. Now I don't, I'm working with a trailer account, so I have certain limitations I have to work with. But if we go back into my diagrams, unfortunately, it did not save that for me, probably because of the limitation I have working with just a trial account. But you get the point. At any time, you can connect to your data warehouse on Snowflake. If you have a very complex environment, you can always reverse engineer that, bring that into your data modeling tool, and then allow for collaboration, allow for the team sport. So data modeling becomes a team sport where everyone can participate. As we saw, you can invite members, you can share this, they can collaborate, document, you can forward engineer, and then when needed, you can reverse engineer. And now you've got all your code in one environment. So now that brings us, I think, to the end of the demo here of SQLDBM. One other aspect that we want to talk about before we wrap up from here is version control and integration into your SDLC. So if we have SQL DBM being kind of almost your repository for your very important data artifacts and SQL DDLs, having an integration into your source code or into existing pipelines that you have with Git and Azure DevOps and a lot of Bitbucket and a lot of different tools out there would be very, very relevant. And so what they have here is plugins, and I haven't gone through to try the plugins. It might require an enterprise version for me to try that, but just so you have an idea, there seem to be plugins that you can connect SQLDBM to your source control types of tools to integrate to version control your DDLs. So as you're creating those DDLs, you have it all version control within the tool. I think if you click on that, you might put in a request and get access to it from a corporate perspective or from an enterprise perspective. But just knowing that that feature is available, I think is always a very, very big plus. That way you have your data in Snowflake, you have your DDLs and your models in SQLDBM, and all your scripts, especially for your DDL scripts, your data definition language scripts, are all version control securely within Git, if that's what you use, or GitHub or GitLab or any of the ones that you use within your flow. So guys, I think that brings us to the end of the presentation here. Just to wrap this up, we've seen data modeling is becoming a very important aspect of the data ecosystem. It's a very busy landscape, but teams are always looking to design and to document and to understand in a very consistent fashion the tables and the objects they have, as well as the relationships within the objects. And they want to do this in a very easy fashion, in a very collaborative fashion, using a modern stack where you don't have to install lots and lots of things on-prem. And SQLDBM here really gives you that flexibility. It gives you the ability to do that and really have a robust integration into the modern ecosystem like Snowflake. And working on Snowflake, SQLDBM is part of the Partner Connect. So if you go into Partner Connect on Snowflake, you can see SQLDBM is available in there. And there's very tight integration between SQLDBM in this case and Snowflake in here. And you can basically switch your account if you want to go through that tight integration. So switch to account admin. I haven't tried this before, but we can go ahead and try it right here before we close this off. So switch to account admin if you have the privileges for that. Just go to SQLDBM, select the database that we want, and you can see SQLDBM requires the following information to create a new trial account, which I've already done, and then you can go ahead and connect. What this does is it links into your account, and just like that, my SQLDBM account is linked back to my Snowflake account, which we already did because I created the connection. But I think you kind of get the point that there is that tight integration between the two tools. So as you're creating your DDLs here in SQLDBM, that tight integration, given that it's part of the Partner Connect in Snowflake, allows you to seamlessly move back and forth within the tool. So just another dimension to be very aware of. All right, guys. So there you have it. I think we've come to the end of the presentation. Hopefully, and the end of the lecture. Hopefully, this was helpful. Hopefully, this gives you some pointers. If you want to go ahead and try out SQLDBM, I'm going to leave some links to the description below. Connect that to your Snowflake account. And if you have any questions about data modeling or comments about what you've seen today, or just feedback in terms of how you use data modeling within your tech stack, within your data engineering ecosystem, let us know. Just share your thoughts, share your comments in the comment section below, and I'll be more than happy to read those and to engage with them. As always, you have been awesome. I've been through. Thanks for watching. I'll see you in our next lecture.